Welcome. In this presentation I'm going to introduce one of the methods used to visually represent systems. This method is called signal flow graph. I'm going to navigate through many web pages to demonstrate this method. That's well within the scope of our course entitled Modern Techniques for System Analysis. This course is animated by Professor Adam Skorek. As you see in this web page, the signal flow graph is represented by a block diagram in which small circles that you see here called nodes. These nodes represent variables of the systems, and the nodes, as you see, are connected by lines called branches, which represent one-way signal multipliers. An arrow, these small arrows of the line indicates direction of signal flow, and a letter, for example here A, B, C or D, near the arrow indicates the multiplication factor. Each system can be represented by this way, and there are many techniques used to reduce the signal flow graph. We are going to have a look to some of these techniques. In the other web page we can see the equivalent elementary techniques used to reduce the signal flow graph. For example, here we have two parallel branches that can be reduced to one branch by adding the two multipliers of these branches. Also here we can reduce the number of nodes. Instead of 3 nodes we will obtain two nodes. Same way here, 4 nodes were reduced to 3, and etc. Also we can collapse feedback loops, as you can see here, so we get the equivalent here. So whatever the complexity of the system of the signal flow graph, it can be reduced using these techniques, and this method is used in many areas of engineering. It's commonly applied to areas as diverse as automatic control and data communication, etc. Now in this example we're going to have a look to how to solve a 3x3 matrix using this technique. As you see here, the matrix is written in form of equations. These equations can be represented in using the signal flow graph method, and using the different techniques we can reduce our signal flow graph, and then using Mason's rule we can obtain the results of our variables x, y, z, etc. Here the rest of the procedure that shows how to proceed with solving this 3x3 matrix. And as you see, it's a very efficient tool that engineers or students can use to simplify the complex equations and the complex systems. I hope that you got an idea about how to use and how this tool is efficient to be used in solving such systems. Thank you very much.